Today I'm going to do a presentation on the three-tier architecture. My name is Leonard. I will be diving into what a three-tier architecture is, and by the end of this presentation, you will have a better understanding of how this architecture works and why it's so effective. So, what exactly is a three-tier architect? A three-tier architect is a client-server software architect pattern that separates application into three logical and physical computing tiers. These tiers are presentation slash web tier, application logical tier, and data tier. Each tier is designed to manage specific aspects of an application, enhancing scalability, maintainability, and flexibility. The presentation tier, also known as the user interface layer, is the topmost level of the application. This tier is responsible for displaying information to the user and capturing user input. It serves as the interface between users and the application. It includes web browsers, mobile apps, or desktop applications where users interact with this application. Common technology used in the presentation tier is HTML, CSS, JavaScript, and you got front-end frameworks like React, Angular, Vue, and etc. An example is sometimes when you interact with the presentation tiers when you go online, when you visit an online store, you go through web pages, navigating to like forms, clicking on buttons are all part of the presentation tier. In the presentation tier, the user Nginx is often used in this tier as a web server and a reverse proxy. It can effectively serve static content, handle SSL and TSL terminations, and route requests to the backend servers, improving overall performance and security of the web interface. The application tier, also known as the business logic layer or the middle layer, is the heart of the application where all the processing happens. This tier processes user requests, responds, applies business rules, or manages application operations. It acts as a bridge between the presentation tier and the data tier. It includes core functionalities of the application such as algorithms, business rules, and workflow. Common technologies used in the logical tier are Java, .NET, Node.js, Python, and Ruby on Rails. An example of when you will interact with anybody will interact with the logic tier is when when you're on an online store and the logic part is the part that processes your order, calculates your prices, taxes, and applies discounts and manages the checkout process. In the logic tier, they use the PM2 is used to manage a Node.js application process. It ensures like high availability and reliability by automatically restarting the application if they crash, or balancing the loads across multiple instances, providing monitoring and login management capabilities. Then you have the data tier. The data tier is also known as the database layer or the storage tier, is where the application's data is stored and managed. It is responsible for storing, retrieving, maintaining data. It ensures data integrity, security, and performance. It includes databases and data management systems. Common technologies used in this are relational databases like MySQL, PostgreSQL, Oracle, and now NoSQL databases like MongoDB, Cassandra, as well as like cloud services solutions. Only time in the online store, the data tier stores product information, user details, other histories, inventories, and inventory levels. So you want to know, why do you choose to use a three-tier web application? I guess one of the main reasons to choose for is modularity, the scalability, and security. Why? There's a prominent reason for using a three-tier architect. The three-tier architect divides the application into three distinct layers, the presentation layer, the logic, and the data. The separation allows for independent development and maintenance, scaling of each layer, leading to a cleaner and more manageable code, and which manageable code is what every engineer wants. The scalability for each tier can be scaled independently based on the demand. For example, the presentation can be scaled out to handle more users' requests, while the logic tier can be scaled to handle complex processing, and data tier can be scaled to accommodate increased data storage. The changes to the one tier can be made without affecting the others. For example, updating the user interface in the presentation tier does not require changes to the business logic or the data across the layers. The 3-tier enhances security by allowing each layer to implement its own security measures. As you can see on the diagram, each one has its own security. So for instance, the data tier can protect the database level security, while the larger tier can enforce the business rules and authentication, and the presentation tier can handle users validation. By distributing the workload across each different servers or services, each tier can optimize for specific tasks, improving overall performance of the application. The components of each tier are reusable, so you can use them across different projects or applications. Like the larger tier can develop from one application, can be reused and saved and develop on a different application to save time and effective and effort. With clear separations between each layer, developers can work on different layers simultaneously, improving collaboration and speeding up the development process. So let's go into the console so we can get a better understanding of how this all works and how it's all running. So okay, now with the AWS console, I'm gonna walk you through how the 3-tier architect was built. First, we'll start with the VPC. It's basically called a virtual private cloud. It's a virtual isolated network in AWS that controls network settings, network securities. When we initially created a VPC, we had to make a large enough slider range to allow us to create multiple subnets in the VPC, because since we're using two availability zones, availability zone 1, availability zone 2, which you will see at the upper right corner. We're currently running in US 1, so we're going to be using US East 1 and US East 2 availability zones. So we had to make a slider range, which you did at, you see the bottom, 16, the subnet mask 16, which will give us enough IP addresses to create 6 subnets. So since it's a 3-tier architect, we needed to create a subnet for each tier. You got a subnet for the app tier, a subnet for the web tier, and a subnet for the DB tier. But since we're using 2 availability zones, we also had to make sure that we had a subnet for the availability zone 1 and a subnet for availability zone 2. So that means that we had to make 6 subnets. As you can see on the screen, we made 2 subnets for the web tier, 2 subnets for the DB tier, and 2 subnets for the app tier for both availability zones. So, and after that, we needed a way to direct the traffic from the internet to the public subnet. So with this, we made we had to make an internet gateway, which allows us to communicate between the internet and the VPC. So we went to the internet gateway, and we created an internet gateway and attached the internet gateway to our current VPC, which would have gave us access to the internet from the VPC. So in order for us to route traffic to the internet, the subnet needs to be associated with a route table. So in that we had to make route tables, which we made 3 of them: a public route table and 2 private route tables. The public route table, we had associated to as you can see, we had associated the public route tables to the 2 public subnets, so which allowed them to receive, which allowed direct traffic within the VPC to defining pathways for proper networking routing. And then we created 2 private route tables, one for the app tier in availability zone 1, as you can see, and then we did one for the app tier in availability zone 2. But these route tables were connected to internet, because we don't want outside internet access to these route tables or to the app tier. What we had to do is we had to create a NAT gateway, which is like a security. NAT gateway is like a security that allows the private subnets to have access allows to have internet access, but also while preventing inbound traffic from the outside internet. So as you can see, each NAT gateway was connected to their corresponding private subnet in that available zone. So the NAT gateway in the available zone 1 is connected to the private subnet of the app tier in available zone 1, and the NAT gateway in available zone 2 was connected to the private app tier in the available zone 2. As you can, if I can show you the resource maps, you can see that this breaker allow traffic connection to like ease to each one of them. See, you see the app had a private route table which connected to the NAT gateway, and the DB had its own route table. I'll explain when we go to the DB tier, and the public have a public table that route to the internet gateway. This is what allowed internet traffic. So let's go to the web tier, so you can see more about how this is the components of the web tier, how it works. So we're gonna go to the EC2 instance. As you can see, when we originally made the 3 tier, we originally made a web instance, a web tier instance, and with this instance, we had to create EC2, and we had to create the EC2 instance. We had the EC2 instance, a load balancer, and auto scaling, and we had to also create external entry point, because in order for us to do the auto scaling, we need to be able to have basically like an original copy. So with that, we made the instance based on what we wanted. So we had it attached to the VPC, the subnet we wanted, and then at the same time we attached the IAM to it. The IAM is basically like it's like a template that takes a copy of this EC2 that's going to be used later on. I'll show it to you when we get to that point. So after we made the instance, we went to our load balancer. You see the web tier, and then we created an elastic load balancer which handles distribution of traffic in the available zones and does a health check, and the traffic will be routed to the healthy instance. So with the load balancer, let me show you like a setup of exactly that. That the load balancer actually is working. I'm gonna take a copy of the DNS and paste it into a web browser so you show that it's working. You see that it's working, it's up and running. So with the load balancer, how it does is that it has a listening point. It goes on your listening point of 80, and it takes the web. It takes whatever information comes from the web, and then come from the application, and posts it up on the web. So with the load balancer, how it works is that it's basically like it's basically, okay, how can I explain it? So how it works is that with the load balancer, with the auto scaling and the load balancer, what it does is that when we attach the IAM, when it made the copy of the instance, it also made we also have to make like a, a launch template for the EC2 instance. So in the launch template, basically we gotta give like it basically what a launch template is like. It basically makes a it just takes a picture of the web tier, and with that picture of the web tier, it will use that the load balancer will use that to spin up when something happens to the web tier, if it's a crash, or if it like is if the server overloads and something just goes down, it will use that. It was use a launch template as a way to like take the information where it came from the IM, because the IM is basically a machine image, and uses that to spin up a new EC2 instance. So you won't have no faulty, you'll be able to like consistently keep on working whether there's any kind of damage to your EC2 instance. So let me show an example. I mean, I don't think I'm gonna probably explain it properly. So let me go to one of my EC2 instance, and I'm gonna destroy it, and you'll see that the load balancer will basically like spin up a new EC2 instance. It doesn't, it takes a while for it to happen, and while this is happening, your load balance will direct the traffic to the other instance while the other one is loading up, so you will never, on the user's end side, there won't be no kind of lagging or like crashing or any kind of situation, where they'll still be able to run at a sufficient pace. So while this is working out, we can talk about the app tier. The app tier also has the same kind of configuration as the web tier. Only difference is the web tier load balance is an external load balancer, where it takes the information from the outside coming. The app tier's load balance is an internal load balancer, and it listens on a different port. It listens on port 4000. Let me find that for you. It listens on port 4000, as you can see here. This is on port 4000. Where is it at? This is on port 4000. As you can see, I was running. I was on port 4000. As you can see, I was running a simulation of this earlier on, and it tells you whether or not which one of your do the app tier target group. It basically kind of gives you like a health check to tell you whether your instance is healthy, or whether it's running, or if it's down. At first, I've been working on it all day to finish sure to get both of them running. Originally, both of them was unhealthy, and now one is unhealthy. So I will continue work on that to make the other two healthy, so I can have a continuous flow. Because this is exactly the reason why you build a 3-tier architect, because if one is down, the other one is always up to help spin it up and continue the workflow, and it won't interrupt your work progress. But as you can see, since I have one healthy and one down, I can show you through the session manager that you're still connecting to the internet with the other app tier. Let's go do that. So right now I'm signing in my EC2. I'm signing into my EC2 instance. See, I'm signed in. So now, just to prove that we still have internet connection, even though one instance said that one is healthy, another one is down, we still gonna show you that how the AWS is still be able to stay resilient, high availability, and then you still be able to like have workflow, even though one of them is not working properly. I'm gonna ping Google right now. As you can see, I'm getting pings. That means I still have internet access with my EC2 instance. Then let's go back to the EC2 instance, and let's see if the auto scaling came up on my on the web tier. As you can see, the web tier we just deleted, we just terminated. It responded a new one. You see, web instance, and it's working. All this is done because of all this is done because of the load balance in the auto scaling. It basically allows you to anything happen, it will always spin up on another EC2 instance, and then since you have one working, it will use that one while the other one is spin up a new one, so you can still have continuous workflow. So now let's go to the third tier, which is the data tier. The data tier data instance, that is done through Amazon RDS, which really is more like a how would you say, it's like basically a place where you store your SQL servers. It's like a high performance managed related database. It's very important. It's like if you want to do your CRUD and your CRUD applications. It's still similar to how the app tier and the web tier is, because is that you have a reader instance, you have your writer instance and your reader instance, and with those instances, it has the same effect as how your auto scaling and your load balancing would do. So if something was to ever happen to your writer instance, which actually does the writer instance, which is basically the writer instance basically, if the writer instance will allow like the read and write from the database endpoints, and the reader instance does the replications and helps distributes the read traffic endpoints. So if something was to happen to your writer instance, the reader instance will automatically turn to writer instance while a new reader will spin up to at the same time. For the DB tier, for the data tier instance, it has its own. We had to create its own subnet for this instance, and with that subnet is basically isolated from the other subnets, but it's still in the same availability zone. Let me find it. Where is it? And then the thing about that instance, it will it's normally used for SQL, and because of this one, it allows you to also be able to transfer data from the data tier to the application tier without any kind of problems affecting it. Oh, and then I realized we didn't talk about the security groups. And is it the security groups? I think it was the security groups. Yeah, we didn't talk about the security groups. So the security groups is actually a very important aspect of this build, because what the security groups does is that they allow acts. It's like basically security group is like a firewall. They basically is a continuous firewall and they allow who should have inbound who should have inbound access, and who should have outbound access. So it's basically like they control what comes inbound, what goes outbound. So as you can see in this section, we had to create 5 security groups. One for the database, one for the web tier, a private instance for the app, for the private instance for the app tier, and two for the load balances. So basically, I was having problems with this earlier on. So like, if something was going to go wrong with the web tier security group, that I'm gonna delete it. And if I delete it, that I won't be able to have access to the internet. But I'm gonna show you currently we have access to the internet because it's still attached. So, but I'm gonna go in. So I'm gonna edit inbound rules, and I'm gonna delete each inbound rule, save it, and then let's see, refresh the page, see if it's loading. Let's just make it quicker. Copy it. Oh, you see, bad gateway. As you can see, it says bad gateway. So let me add back my security group to my rules to my security group, and then voila. Thank you for the presentation. Thank you for entertaining my presentation. Sorry for my stumbling. Talk to you next time.